Hi class, this is Neil, and this is a review of page 3 of lesson 9. I know this is a homework that many of you turned in. I will kind of note that many people got questions 3 and 6 incorrect. So I want to really review question 1, and then your assignment will be to do question 3 and 6 and hand that in. All right, so an investment of question 1, we'll read it. An investment of $567 is made into an account that grows at an annual rate of 7.2%, so that's really 0.072, and it's compounded quarterly. So that word compounded is super important. Quarterly means it's happening really 4 times a year. Right, so our end value is 4. Well, what do I mean when I say the end value? Well, if we go back to our compound interest formula, it's the ending amount is equal to what we start with times 1 plus the rate divided by the compounding periods raised to the power of n times t. So in this case, because it's quarterly, our end value is 4. The time we're interested in is 15, after 15 years. So the equation I would really write is A equals what I start with, which is 567, times 1 plus that 0.072 divided by 4, because we're doing it quarterly, raised to the power of 4t. All right, so that's going to be the equation I would need to write for question 1. So for question 3 and 6, for question 3, we're interested in a compound formula that is daily. So you need to think about, if it's daily, what is my end value? How many times does that happen per year? And for question 6, it's a compounding that is happening monthly. So in that instance, you need to decide what is the end value that I'm interested in. So regardless of whether or not you turned in this homework, I do want you to answer questions 3 and 6 here. You can pause the video if you need to write down question 1. All right, so let's just look at practice problem number 1 from set 2. Okay, so we have this function, p of t equals 110 e raised to this power, and it models the population of a city in millions t years after 2010. As of today, consider the following 2 statements. So the first statement is the current population is 110 million, and the second statement is the population increases continuously by approximately 3.9% per year. Okay, so this is a continuous interest problem. So this is kind of the way that formula looks in its sort of standard form. P is what we start with, so that's our starting amount. R here is our rate. Okay, so, and it's our rate as a decimal. So in order to kind of answer this question, we want to think about what are the different parts of this equation mean. So this equation, as it's given to us, is P of t equals 110 e to the 0.03922 t. Okay, so to answer this question, we have these 2 options. You need to interpret what this means. Well, 110, what does that represent? That's what we start with. And that's what we start with in 2010. This number here represents our rate. So our rate is 0.03922, and that is as a decimal. Okay, so that's enough information for you to answer that question. And I'll stop this video here.